Hello, welcome to part 3 of the discussion video for functions as power series. So in this last video, we will answer item number 4 and its 3 sub-items. Okay? So here we are given the power series representation of e to the x, which is the summation from n equals 0 to positive infinity of x raised to n over n factorial. So letter A, we are asked to write this function as a series. Okay? So dito, isusulat lang natin yung e raised to negative t squared as a series gamit yung given na ito. Okay? So substituting negative t squared sa x sa left-hand side, ganun din yung gagawin natin sa right-hand side. So yung x dito magiging negative t squared raised to n. Okay, so doing that, we get this, and then simplifying this, ilalabas natin yung negative 1 raised to n, we get this series. Okay, so now we perform integration with respect to t, and we get this resulting series. So we have the summation from n equals 0 to positive infinity of negative 1 raised to n over n factorial times t raised to 2n plus 1 over 2n plus 1 evaluated from t equals 0 to t equals 1. Okay? When t is equal to 1, so 1 lang ito, our resulting series is the summation from n equals 0 to positive infinity of negative 1 raised to n over n factorial times 2n plus 1. When t is 0, this is 0, so this whole thing becomes 0. Okay? So, ibig sabihin, the integral from 0 to 1/2 of e raised to negative t squared dt is just equal to this series of constant terms. Okay? Next, we want to find a power series representation for x e to the x, and by integrating the series from 0 to 1, we want to show that this equality holds. Okay? So first, hanap muna tayo ng power series representation for x e to the x. So madali na lang to kasi meron na tayong power series representation for e to the x. So ang gagawin lang natin dito, we will multiply x on both sides of this equation. Okay? And then ito, ipapasok natin sa loob ng summation. Okay? Doing that, we get this power series representation for x e to the x. Okay? So now we integrate both sides of this equation from 0 to 1. Okay? So integrating the left-hand side of the above from x equals 0 to x equals 1 by using IBP, we can show that this is equal to 1. Okay? Now integrating the right-hand side from x equals 0 to x equals 1, we get this resulting series that needs to be evaluated from x equals 0 to x equals 1. So when x is 1, we have this resulting series. When x is 0, this becomes 0. Okay? So this is just equal to the summation from n equals 0 to positive infinity of 1 over n factorial times 1 over n plus 2. So now, balik tayo sa ating problem. So observe here that we are being asked to show that the summation from n equals 1 to positive infinity of 1 over n factorial times n plus 2 is equal to 1/2. Okay, so ibig sabihin ang sum ng series of constant terms na ito ay 1/2. Okay? So to show this, i-compare lang natin itong series na ito doon sa series na na-obtain natin. So observe that pareho naman yung terms nila. Tama? Pero, hindi sila pareho ng index. Okay? So, kailangan nating i-adjust ito para makuha ito. Okay? So, doing that, we get this. So, substitute lang natin yung n equals 0 dito. Okay? And then, i-adjust natin yung index nitong ating summation. Okay? So, simplifying, we get 1/2 plus the summation from n equals 1 to positive infinity of 1 over n factorial times n plus 2. So now, ready na tayo na i-equate ito with the value na we obtained for the other side of the function, which is 1. Okay? So doing that, equating the two, we get the integral from 0 to 1 of x e to the x dx is equal to 1. Tama? And then the integral of this series from 0 to 1 is equal to this. Right? Manipulating this, so i-transpose lang natin yung 1/2 sa kabilang side, we'll get this result. So which is exactly what we want to show. Okay? Okay, this last example is left as an exercise for you guys. Okay? So kayo naman, try nyong i-apply yung natutunan natin so far. Find a power series representation for x squared e to the negative x using this given. And then by differentiating the resulting series, show that this equality holds. Okay? So pwede nyong i-comment sa comment section yung inyong sagot, or kung nahihiya kayo, pwede nyo ring i-email sa inyong discussion teacher. Okay? Thank you guys for listening, and I hope may natutunan kayo sa ating discussion na ito.